we're going to sketch the graph of f of x equals 1 plus 2x divided by 1 minus x squared. So again, let's think through. First of all, for our domain, if we take 1 minus x squared and set it equal to 0, we get 1 equals x squared. So x is equal to plus or minus 1. That means that our domain is all real numbers except 1 or negative 1. Writing that in interval notation, we would have negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. Next, for our vertical asymptotes, we would do the exact same thing. We would set 1 minus x squared equal to 0, and we would see that we would have a vertical asymptote at x equals 1 and a vertical asymptote at x equals negative 1, provided that those aren't zeros of the numerator. If we were to substitute 1 in the numerator, we would get 5, which is not 0, so this is a vertical asymptote. And if we substitute in negative 1, we also would not get 0, so this is a vertical asymptote. So going over to our graph, we note that we're going to have a vertical asymptote at 1, and we're going to have a vertical asymptote at negative 1. Next, we want to find our horizontal asymptotes. To find our horizontal asymptote, we have 1 plus 2x over 1 minus x squared. So if we compare the degree of the numerator with the degree of the denominator is greater, which means our horizontal asymptote is y equals 0. So that's just the x-axis. So in order to sketch this graph, note that we have 3 regions instead of just 2, like on our last example. So let's go ahead and substitute in values around our asymptotes. Let's first of all choose a number that is smaller than negative 1, perhaps negative 2, and plug that in our equation. We'll have 1 plus 2 times negative 2 divided by 1 minus negative 2 squared. So we're going to have 1 minus 4, which is negative 3, divided by 1 minus negative 2 squared is 4, so 1 minus 4 is negative 3 again. So we get the answer 1. So at negative 2, our graph is at 1, and that means that this branch, to fall in between our vertical and horizontal asymptotes, would have to look like that. Now let's go on over and let's substitute in positive 2. If we enter positive 2, we're going to have 1 plus 2 times 2 over 1 minus 2 squared. So we're going to end up with 5 divided by negative 3, which is negative 5/3. So when we're at 2, we're down at negative 1 1/3. And so this branch of the graph is going to have to look like this. So in between, we're going to have to just check it out and see what happens in between negative 1 and 1. So we might substitute in some values. If we substitute in 1/2, go ahead and enter that on our calculator, and we're going to get 8/3. So at 1/2, we're up at 1 8/3 would be 2 2/3. So at 1/2, we're up here. If we substitute in 0, we're going to get 1 over 1, which is 1. And then we can substitute in negative 1/2. When we substitute in negative 1/2, we get 0. So we have a graph that looks something like this in between those asymptotes.